All right, just going through some of these you try now problems for you in case you wanted to watch an explanation. First off, we've got this pre-image triangle ABC. We want to rotate it 90 degrees counterclockwise. All right, so I'm going to take my paper and I'm going to rotate it one time to the left, okay, because it's counterclockwise. All right, C prime, I'm going to go to the left 2, up 1, 2, 3, 4. That's C prime. B prime, I'm going to go to the right 1, 2, 3, 1, 2, 3, 4, up 4. And then for A, to go to A prime, I'm going to go to the left 2, down 1, 2, 3, 4, 5, 6. Left 2, down 6. So there are the prime coordinates after rotating 90 degrees counterclockwise about the origin. Okay? So sometimes I find it helpful to write the prime coordinates, even if the final question's not asking for it. So A prime is -2, -2, -6. B prime is 3, 4. And C prime is -2, 4. Okay? So those are our prime coordinates. Next, we're going to translate it by going to the left 4, up 7. Left 4, up 7. So I'm going to go to the left 1, 2, 3, 4, up 7. 1, 2, 3, 4, 5, 6, 7. I'm going to be 1 off my graph for C double prime. 1, 2, 3, 4. And 1 off my graph for B double prime. And A double prime is going to be here. So there is my double... Oh, my goodness, that's a bad line. There's my double prime on the graph. All right, if I wanted to check it, just -2, -6. If I throw that through this translation rule, A double prime is going to be -6. -6, 1. B double prime is going to be -1, 11. And C double prime is going to be -6, 11. Okay? Now, the question here is, does the order affect the final image? Like, if I move this to the left 4 and up 7 first, and then rotated it 90 degrees counterclockwise, would I still get the same end result? So if you try that out, like if I pick a specific coordinate, all right, like if I pick B, if I went to the left 4, up 7 to start, so I'm going to do that in green. If I go to the left 4, up 7 to start, that would be B prime. And if I rotated that 90 degrees counterclockwise, that would be right here. All right, is that the same location as B double prime? Absolutely not. So, does order affect the final image? Yes, it does. Not in every case. There are going to be some situations that if you flipped it around, it would give you the same final image. But the order will affect it, especially if you're rotating. Okay, so a good rule of thumb is just make sure you know that order affects the final image. You got to do it in the way that it's presented to you. Okay? Example 2 says, complete the composition of transformations on this segment. The first thing is a translation. But notice, you don't know the translation rule. You just know that it's some translation. So we're trying to figure out what values of A and B will complete this transformation correctly. Okay? So we don't know how this is being translated. We don't know how this is moving to the left or the right or up or down. But we know after we translate it, we reflect it across or in or over the x-axis. And we are left with F double prime, which is at -2, 6. And G double prime, which is at 1, 4. So we know that's our final image, but we don't know that middle stop. All right, we don't know what happens after this translation. Okay, so here I'm going to work backwards. Okay, I'm going to take f double prime and g double prime, and I'm going to reflect that across the x-axis to see where the prime coordinates were at. So if I reflect this over, g prime would be there, and f double prime would be here. Okay? So I'm kind of working backwards here. I'm taking my double prime and I am working backwards to figure out what the prime coordinates were. Okay? Where, f prime and g prime were at. Okay? Because now that I have all those graphed, I can say, all right, what did I do to f to get to f prime? Well, I went to the right 3. I went to the right 3, and I went down 1, 2, 3, 4, 5, 6, 7, 8. I went down 8. So my transformation rule was I take the x-coordinate and I move it to the right 3, and I take the y-coordinate and I move it down 8. And I can double check that by taking the regular g that I started out with and go to the right 3, down 8. 1, 2, 3, 4, 5, 6, 7, 8. And it matches up with g prime. Okay? So a equals 3 and b equals -8. Because that's what we were trying to find. We were trying to find the a value and the b value that will satisfy this composition. All right? Next up, just another example of what are the rules? What's going on here? All right, so for, first off, to go from ABC to A prime, B prime, C prime, that's a translation. So I take my XY coordinates, and what do I do to it? I go to the right 1, 2, 3, 4, 5, and I go up 1. So I got X plus 5 and Y plus 1. Okay? So that's the first transformation that's happening. And then what do I do? What do I do to go from prime to double prime? Well, that's an enlargement. So we need a couple things here. We need to know our scale factor, and we need to know what it's centered at. All right, so remember, we went over a problem like this back with dilations. We can draw a line connecting the 2 points and see where they intersect. Notice how these all intersect right here at the origin. Okay, so it's centered at 0, 0, or the origin. Now we just need to figure out the scale factor. So to get to A, let's look at the slopes. I go up 2 over 1. To A prime. I go up 2 over 1. To get to A double prime, I go up 4 over 2. So I went from up 2 over 1 to up 4 over 2. What am I doing there? I'm multiplying by 2. So my scale factor is 2, centered at the origin, or centered at 0, 0. So those are my transformations. Let's look for another example just to verify that our scale factor is 2. To get to C prime, I go up 1, 2 over 1, 2, 3. I go up 2 over 3. To get to C double prime, I go up 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6. Okay? Oops, sorry. So I go up 4 over 6. So instead of going up 2 over 3, I go up 4 over 6. I'm multiplying that by 2. So that's why my scale factor is 2. Okay? And then last one here, we have a segment CD. Our first transformation is that we are going to dilate this by a scale factor of 3. So we're given that K equals 3, centered at -1, 0. Okay? So -1, 0. That's right here. That's my center of dilation. Okay, so to manipulate that scale factor of 3, let's manipulate the slopes. So normally to get to C from my center, I go up 1, 2, 3 to the left 1. So instead of going up 3 to the left 1, I need to multiply that by 3 because that's my scale factor. I'm going to go up 1, 2, 3, 9 to the left 3. Up 9 to the left 3, and that's going to be C prime. Okay? And so C prime, the coordinates there are -4, 9. Okay? And then to get to D prime, from my center of dilation to get to D, I go down 2 to the right 1. So instead of going down 2 to the right 1, I'm going to go down 6 to the right 3. So down 6 to the right 3. And that's going to be the location of D prime. Now if I try to connect these, there might be a little bit of overlap. But there's C prime, D prime. Coordinates for D prime are going to be 2, -6. Okay? So, next up, that's transformation 1. Now we got transformation 2. We're going to have to rotate 90 degrees clockwise about the point -1, 1. So here is our center of rotation now. If I rotate this 90 degrees clockwise, let's see here. What are we going to do? To get to C prime, if I turn my paper 1 turn to the right, 90 degrees clockwise, I'm going to go to the right 1, 2, 3, 4, 5, 6, 7, 8, up 1, 2, 3. So from my center of rotation, I'm going to go to the right 1, 2, 3, 4, 5, 6, 7, 8, up 3. And there is C double prime. To get to D, turn my paper. From my center of rotation, I go to the left 1, 2, 3, 4, 5, 6, 7, down 1, 2, 3. Left 7, down 3. So I'm going to go to the left 1, 2, 3, 4, 5, 6, 7, down 3. And there is D double prime. Connect the dots. So C double prime, the coordinates there are 7, 4. And D double prime, those coordinates are -8, -2. Okay? So, good examples there. Good quiz, good test questions. They're more challenging when you're centered not at the origin. So make sure you practice those. Let me know how I can help. Good luck. Practice, practice, practice. Have a good one.